Hi, my name is Chen Sagiv. I'm co-founder and co-CEO of Pathology, a company that brings artificial intelligence to digital pathology. I'm going to talk to you about the second AI revolution and democratizing AI creation in healthcare. Now, health advances that actually change the world involve anesthesia, sanitization brought about by Florence Nightingale, antibiotics, and of course, vaccines, which is something that we all talk about nowadays. But even today, there are still things in healthcare that belong to the analog world. Things like glass slides that obtain biopsies, things like paper folders containing patient information, and also X-ray films from radiology. Although radiology went through the digital revolution already 20 years ago, this still exists. Digitation is a process that has been going on for the last 20 years in several healthcare domains, and this is actually a game changer. First, because it allows us to send information, digital health information, via email, send the images for second opinion, and also consult with colleagues via a network communication. But digitation is also the enabler of algorithms. Once this information becomes digital files, you can apply signal processing, image processing, and more algorithms to extract valuable information for patient treatment and diagnostics. And one of the major possibilities of application of algorithms on digital health information is artificial intelligence. And what I'm going to talk about today is how artificial intelligence is going to change our life, to make us healthier, and also to allow us to recover from illness faster and much, much better. So, what's AI all about? AI means that you extract valuable information from data. And doing that took us actually many, many years, because artificial intelligence is rooted back in the 50s, and then it was very, very hypey, and everybody was excited about that. But there was a very long artificial intelligence winter because there was a gap between the fantastic mathematical theory and the lack of ability to apply artificial intelligence in real-life use cases. Then, in the 90s, artificial intelligence started gaining some momentum again, and in 2012, something happened that made artificial intelligence penetrate our lives and actually change the world as we know it today. So, what happened in 2012? One of the landmarks in the history of artificial intelligence is the ImageNet competition and what happened in 2012. The ImageNet is a computer vision challenge where the participants are asked to classify hundreds and thousands of images to hundreds of classes. And in 2012, it was the first time that a deep learning neural network called the AlexNet was applied and was the absolute winner, leaving everybody else far, far behind. And the AlexNet was actually a convolutional neural network that provided excellent results. Now, how come that in 2012 this actually happened? And the answer to that is double-fold. First, in 2012, we had enough compute power, which we could use locally in our house or at the university to apply neural networks on data. And the second thing is that we started having enough amounts of data to train our neural networks. And these two things are actually the enablers of the application of neural networks to real-life problems and also to bring artificial intelligence from theory to practice. So, just to give you a small flavor of artificial intelligence, the basic structure in neural network is the perceptron. You can see that this is something which is already 51 years old, and a perceptron is actually a node which gets a lot of inputs and also provides an output in if the inputs exceed some value, if they exceed some amount of threshold. And if you connect many of these nodes together and you create hundreds of layers and a very, very complex structure called a neural network, then you have a mathematical creature that is able to make very, very complicated decisions and handle a lot of data, solving problems such as classification, detection, segmentation, and much more. So this is just a little bit on artificial intelligence. COVID-19, that is part of our life in the last 9 or 10 months, actually did promotion to digital health and to the application of artificial intelligence algorithms into healthcare, because people realized that they need the data to be digital, they need the data to be transformed via the networks in order to be able to work from home, to work from afar. And also the race to vaccines, the race to better treatment for COVID, and also for the monitoring of the COVID, really promoted the use of artificial intelligence models, and this actually boosted and the need to use AI in healthcare. But you know, coronavirus is not the only illness in the world. There are more illnesses, and one of the trends which is happening in the last few years is the number of patients is increasing because the population becomes older, while the number of medical doctors is decreasing. And this introduces a tremendous challenge to the healthcare system. And moreover, the amount of new information available to the medical doctors is enormous. And there is a risk of drowning in this huge amount of data. One medical doctor cannot master all the information within a field like pathology. You need to be a subspecialist. And this calls for the help of algorithms, for the help of automation in order to keep healthcare in a good level. Now, application of AI algorithms in healthcare is very, very widespread in the last few years or even the last decade. And what is usually being done is that companies are tackling one problem. They are looking for the problem, they look for the data, they need annotations, and then they ask the medical doctor, please give us all this information, and they start developing a solution. It takes a lot of time and a lot of money, and eventually they provide a black box solution that is able to solve one single problem. Now, some examples. This is Google's application for the detection of breast cancer, which actually surpasses the performance of a specialist radiologist. This is a phone application that actually monitors the risk of arrhythmia through just taking a picture of our finger. This is a Helicobacter pylori detector, which is an artificial intelligence algorithm applied to a pathology image. And AI is also penetrating the operating room. Just imagine that in each operating room, you will have an AI system that would give the surgeon alerts on what he can and can't do. So all of this is fantastic, but there are so many problems in digital healthcare that the need to have skilled R&D teams, the need to invest long development cycles and to have access to strong hardware and large amounts of data all of this make the progress and of the penetration of AI solutions into healthcare very, very slow. Moreover, the medical doctor is actually not in the loop. The data, the knowledge is brought to the AI experts, and they are the ones who are supposed to create the AI solution. But healthcare has thousands of tasks waiting for AI, and this calls for a change of mind. This calls for a new, completely new approach. The solutions are human-centric, not only in the sense that the solutions should be empathic to the patients, but also that the solutions should be personalized. And the whole concept of personalized healthcare actually relies on application of AI to several problems in medical healthcare. The idea that the switch that we need to make is, rather than bringing the data to the hands of the AI experts, we should bring the AI ability to the hands of the medical experts. And this will allow scaling up of AI creations in digital health. Now, our company, Pathology, has developed the studio. The studio is an AI-powered solutions generator that allows pathologists to create by themselves several kinds of solutions to various common problems in pathology, where the vision is to bring rapid AI creation to every pathologist or to every medical doctor, and to allow scalable AI deployment of these solutions. The concept is the concept of do-it-yourself platforms that allows the medical experts to create and deploy by themselves AI solutions very quickly, relying on small amount of data in their own lab without being AI experts. And if we are successful in doing that, bring the AI tools to the hands of the experts, the medical experts, or the transportation experts, or any other experts who are not AI experts, then we could really scale up the penetration of AI into several domains in our lives. Now, the Pathology Studio, how do we do that? We have targeted 4 kinds of problems. One is region segmentation. The second is cells detection and quantification, objects localization and classification, and also tiles. Tiles is very similar to regions, but it's very, very rapid because you are dividing the image into tiles. And based on these 4 basic modules, the user can actually teach our system what they are looking for. And the way that they teach the system is by giving it examples. Examples of what they are looking for, and negative examples of the things that they are not looking for. And by giving these examples, our system, our platform, actually adapts the basic modules to be able to solve the problems that the user is tackling. And using this platform, we could actually, or not us, actually our users could develop solutions for beta amyloid plaque detectors, which is an indicator of the Alzheimer's disease, lung cancer tissue segmentation, Ki-67 quantification, which is indicator of cancer, and many more algorithms. And these solutions, these algorithms, were created by the medical experts. So they brought their expertise and were able to create these AI solutions. But we only got started because this kind of platforms will allow the medical experts to create solutions to prevent diseases, in the sense that we will be able to monitor people and give alerts in advance for risky situations. They will allow better diagnosis of specific illnesses, in the sense that we will be able to bring expertise of very, very rare disease to be widespread and available to other physicians. And also something which is critical and is now many companies are working on, that of personalized therapy, personalized healthcare. This means that if you will need a treatment, the treatment will be adjusted specifically to you, according to your data, according to your pathology results, according to your radiology results. And this will actually will make recovery from illnesses much safer, and also it will have more promising results. Now, so this can happen, and this is already happening today. But there is also another gap that we have to account for. It's very good that medical doctors and pathologists will have these solutions available in their offices, in their lab, and they will be able to play around with AI and create innovative solutions. But the gap that we have to fill is to actually scale it up. So it goes beyond a single doctor in a single clinic, and something which will happen in a hospital level, in a land level, and also will be able to communicate doctors and the caregivers throughout the world. So how can we do that? And the challenge would be to deploy AI at scale in order to have impact. Because if we do not scale it up, then we don't have impact, and we will not affect the well-being of patients. Now, a very nice example that I found is the application of a platform, of a digital platform of SAP in Charité. Charité is the largest university hospital in Germany, and one of the projects that they have been doing in the last few years is actually creating one platform to unify all the patient information, having everything accessible, all the data, all the images, all the details of treatment, and making it available throughout the hospital while keeping patient information safe, which is also very, very critical. And as you can see here, this kind of platform actually integrates information from the various departments, and this is an infrastructure that allows the modules of AI to be seamlessly integrated into a larger data management system, which allows approaching the data, archiving this data, and also using it in between departments and between doctors. I would like to conclude and say that artificial intelligence is sometimes pictured as the bad robot, as this malicious robot who actually wants to control the world. This is in the good case, or actually wants to eliminate all of us, and this is the worst case. And the truth is that treating artificial intelligence as bad or as good really depends on us, the human beings. And I strongly believe that artificial intelligence can serve us for good. It can bring digital health into the next level. It can allow the generation of sophisticated solutions that will enhance health, that will make us live better, live longer, and this is really up to us. Thank you.